So this is keto form because it has a ketone group. And let us write another tautomer of this compound. For writing tautomers, we are looking for two things. One is a double bond and another is a alpha hydrogen. So we have a double bond here, and this carbon is called alpha carbon, and corresponding hydrogen is alpha hydrogen. So we must have at least one alpha hydrogen. Now we can write tautomer of this compound. So this bond, the bond with alpha carbon, can be broken and it can form a pi bond. So hydrogen changes its position from carbon to oxygen, and there is a double bond. Now this is enol form. So it has in group, it has a all group. So this is enol form. This is keto form. Let us write tautomer of this compound. So in this case again we have a alpha hydrogen. So we can break this bond here and push this bond here. So we can write another tautomer. So this is keto form and this is enol form because it has a in functional group and it has a all functional group. Now let us try this problem. So we have to write another tautomer of this compound. Now in this case we does not have any alpha hydrogen, so this carbon is alpha carbon. We have 3 methyl group attached to this carbon, so in this case no alpha hydrogen. So tautomerization is not possible in this case. Now let us write tautomer of this compound. This molecule is enol form and this is called phenol. So this molecule has a name and this is called phenol. We have to write tautomer of phenol. Now where we have a double bond and this is alpha atom. This time at alpha position we have oxygen atom and this hydrogen is alpha hydrogen. So we can push this bond here and we can push this bond here. So we will have this tautomer. This is the keto form. In this case, enol form will be more stable because it has a aromatic ring. Keto form is less stable because it does not have aromatic ring. So in case of phenol, enol form is more stable. And the reason is aromaticity. Now let us write tautomer of this compound. This carbon is alpha carbon. We have a alpha hydrogen. This carbon is beta carbon, and this carbon is gamma carbon. This hydrogen is gamma hydrogen. Now this time alpha hydrogen does not participate in tautomerization. So you can try yourself. This goes here. This goes here. So in that case, so this carbon becomes sp hybridized. Sp hybridized means angle is 180 degree, but this angle is 120 degree. So geometry does not allow an angle of 180 degree. So this tautomerism is not possible. So due to geometry, we can say alpha hydrogen does not participate in tautomerism. But this time gamma hydrogen can participate because that is in conjugation. So we can break this bond here. This bond goes here and this goes here. So we can write all form, enol form. So this is the enol form and this is keto form. So this time gamma hydrogen participates in tautomerism. So not necessarily only the alpha hydrogen participates in tautomerism. You can have any hydrogen that is in conjugation. So important point is hydrogen that is conjugated with double bond can also participate in tautomerism. For example, you can try this problem. So you see, this time this double bond is conjugated with this double bond, and then this double bond is conjugated with this double bond. Further, this is conjugated with this double bond. So this hydrogen will participate in tautomerism. So we can show tautomerization in this case. So this bond goes here, this goes here. So this is your keto form. So this is keto form. And then we can write enol form. So both ring becomes aromatic in this case. So enol form will be more stable. So we have an aromatic ring. So this ring is aromatic. And this ring is also aromatic. So let us try this problem. So we have to write enol form. So this is keto form. This time we can do 3 times tautomerization, or we can say 3 hydrogen that participates in tautomerization. This goes here. Similarly, so we can have a double bond at these 2 carbon. A double bond we will have here and one double bond here. So basically 3 hydrogen that participates in tautomerization, this hydrogen, this hydrogen and this hydrogen. These hydrogens can also participate. So this one and this one can also participate in tautomerization. So we can say in this case we have 6 tautomerizable hydrogen. So we have 6 tautomerizable hydrogen. Tautomerizable means the hydrogen that can participate in tautomerization. So tautomerizable hydrogen means this means hydrogen that participates in tautomerization. Now let us say if I have this molecule, this molecule will not show tautomerization. Can you explain? So no tautomerization. You have to explain. Once again, this carbon is alpha carbon and this carbon is also a alpha carbon. So at this carbon we does not have any hydrogen. So we does not have any alpha hydrogen, but this carbon we have a alpha hydrogen. So this hydrogen can participate in tautomerization. So if I do that, now this carbon becomes sp2 hybridized because it has 3 groups 1, 2, 3. So this becomes sp2 hybridized. For sp2 hybrid orbitals, bond angle should be 120 degree. But in this case, geometry does not allow a bond angle of 120 degree. So this hydrogen does not participate in tautomerization. So geometry does not allow bond angle of 120 degree. This bond angle cannot be 120 degree. This bond angle cannot be 120 degree. So geometry does not allow a bond angle of 120 degree. So we can say any hydrogen that is at bridgehead position will not participate in tautomerization. So any hydrogen at bridgehead carbon will not participate in tautomerization. For example, if I ask, will this compound show tautomerization or not? So compound will show tautomerization so you have to answer in yes or no. Now at this hydrogen, at this carbon we have a hydrogen, but that hydrogen is at bridgehead position and this hydrogen is also at bridgehead position. And hydrogen that is at bridgehead position does not participate in hyperconjugation, basically tautomerization, not hyperconjugation. So this compound will not show tautomerization. Let us write tautomer of this compound. Now we have a double bond. this is alpha carbon and this is alpha hydrogen, and this time alpha atom is nitrogen. Now we can do the same thing. This bond goes here, or we can force this bond this side. Let me make another structure. So this bond goes here, this goes here. So if I follow the arrow, we will have nitrogen, nitrogen, and here we have OH group, OH group, OH group. Nitrogen will have a lone pair of electron. So this is the tautomer of this compound. So whenever we have to write tautomers, we have to look at a double bond, and we have to look at alpha hydrogen, and we have to change the position of double bond and change the position of alpha hydrogen. So we have to change the position of double bond and alpha hydrogen to get the another tautomer.